When you're multiplying two fractions, the goal is to factor each numerator, factor each denominator completely, and only then cancel any like binomial factors. One binomial from the top, then one binomial from the bottom. So x squared plus 5x plus 4 factors into x plus 1 times x plus 4. You can check the middle terms. 1x plus 4x is 5x. We have x squared minus 6x plus 8, which will be x minus 4 times x minus 2. X squared plus 5x plus 14 should be x plus 7 times x minus 2. And this last second denominator should be x plus 7 times x plus 1. Those factorizations can be checked. Now we're looking for like factors in the top and the bottom. Notice we cannot cancel the x's, this x and this x, because x is not a factor. It's not part of a multiplication problem. This is a factor. It's one of two things being multiplied together. That's what a factor is. So this binomial factor cancels this one. This x minus 2 cancels this one. This x plus 1 cancels this one. One from the top, one from the bottom. And now we're left with an x plus 4 on top and an x minus 4 on the bottom. It does not cancel to 1 because the top and the bottom are not equal to each other. The question is, does it cancel to negative 1? It will cancel to negative 1 if these two binomials are opposites of each other. Now how do we know if they're opposites of each other? If you add them and get 0, they're opposites. 4 plus negative 4 is 0, but x plus x is 2x. So when you add these two binomials, you don't get 0, so they are not opposites of each other. Another, maybe easier way of looking at it is if you think these two are opposites of each other, then when you put in a number, you should get opposites. So like if you put in x equals 7, you get 11 on top and you get 3 on the bottom, and those aren't opposites of each other. So this isn't going to cancel to negative 1. It can be lots of different things. So the final answer here is x plus 4 over x minus 4. And that's as reduced as it can be. In the last problem we had a division, so we multiplied by the reciprocal of the second fraction. This time we have a multiplication. We're going to follow the same plan. Factor everything, cancel like factors, and be done. So this first numerator, a 12 factors out. That's about all we can do. In the first denominator, a 5 factors out. And that's about all we can do. Second numerator, a 3 factors out. But once we factor out the 3, then we have a difference of two perfect squares, and that factors some more. And in the denominator here, we can factor out an 8. But then we have a difference of two perfect squares, and that factors some more. Now we're looking around for like factors to cancel. This y plus 5 can cancel this y plus 5, one on top, one on the bottom. Y's plus 1's, one on the top, one on the bottom. 5 on the bottom does not cancel with a 12 or a 3. An 8 does not cancel with a 3, but an 8 cancels with a 12. 4 goes into 8 2 times, 4 goes into 12 3 times. So now let's deal with the numbers. On the top we have 3 times 3, which is 9. And on the bottom we have 5 times 2, which is 10. On the top we have a binomial factor of y minus 5. On the bottom we have a binomial factor of y minus 1. There's no more canceling. We're done. So what you can say about multiplications and in essence divisions that you turn into multiplications, you factor the top and the bottom of all fractions completely and then cancel like factors carefully and then be done.